Okay, so let's extend the polynomials to cubics and to quartics. We already know about the roots of quadratics and how they're related together. In this video, we're going to look a little bit about quartics, and cubics, and maybe even a little bit on quartics as well. So let's think about this expansion. So we've got a cubic, and the roots are alpha, beta, and gamma. So we can write it in factorized form. Let's expand this out, and then compare it with like the general form of a cubic, and see how the roots relate to these coefficients. Again, you might want to pause and try this expansion before I do it. So we're going to get x squared minus alpha x minus beta x plus alpha beta multiply everything by x minus gamma. We're going to get x cubed minus gamma x squared minus alpha x squared plus alpha gamma x minus beta x squared plus beta gamma x plus alpha beta x minus alpha beta gamma. Okay, remember we're trying to compare it with this general form of a cubic. So let's just tidy up and group our terms. We've got x cubed, x squared, and look at the x squared terms, minus alpha minus gamma minus beta. So we could write that as minus alpha plus beta plus gamma x squared. Next, if we focus on the x coefficients, they're all positive, so that would be plus alpha beta plus alpha gamma plus beta gamma x, and then finally we end with minus the product alpha beta gamma. So if we compare this with the standard form, again the coefficient is 1, so if we divide this throughout, we can say that x cubed plus b over a x squared plus c over a x plus d over a would be equal to 0, and just one little trick with the minuses so we can compare these. I'm going to write it as x cubed minus b over a x squared plus c over a x minus d over a. And if we compare the expression in terms of the roots with the expression in terms of the coefficients, hopefully we can see that the sum of the roots, alpha plus beta plus gamma, which I'm going to start to write in the sum notation. That's going to be really useful as these questions get a little bit more heavy on the algebra. Like, you want to write it in sum notation sometimes, but you could write it as alpha plus beta plus gamma. You could also write it as the sum of the roots. Because it doesn't matter which root's which, alpha, beta or gamma, so like we just say the sum of the roots. And this, convention we use alpha, but you could write the sum of beta if you want, it would be the same thing. So the sum of the roots we can see is minus b over a. Hopefully that looks familiar, like that's the same, isn't it? And then we've got the pairs, alpha beta plus beta gamma plus alpha gamma, which we would write as the sum of the pairs. And essentially, if we multiply two roots together and add them up, there's all the possible combinations we could write like this. That would equal the pairs is the coefficient of x, so that's c over a. And finally the product, alpha beta gamma, which I'm not going to write as a summation because it's just the product of the roots. We can see that that would be minus d over a. Okay. You want to highlight this in your notes, and once we've got that, maybe you just pause and have a think about what would happen if it was a quartic. Like we've done it for a cubic. We know what a quadratic is. We've just figured out what the cubic is. You can, if you really want to, you could expand like 4 brackets And for a quartic, the other root we would call delta. You could expand all that out if you want, but it might take a little bit of time, so I'm going to skip over that, and we'll see what the relationship is for the roots in general. So for a quartic, we've got 4 roots, alpha, beta, gamma, and delta. The sum of the roots which I'm going to write as the sum of the roots, is still minus b over a. It's always minus b over a, no matter how high up you go. Okay. Then we've got to think about the pairs, so alpha, beta, plus alpha, gamma, plus alpha, delta, plus beta, gamma, plus beta, delta, plus gamma, delta. And you can see why I'm not going to write that out. That's just the sum of the pairs of roots. That would be equivalent to c over a. Then we've got the triples, which is the sum of alpha, beta, gamma. That would be alpha, beta, gamma, plus alpha, beta, delta, and all possible combinations, okay? And the pair, sorry, the triples is minus d over a. And then finally, the product of the roots, which is not a sum, it's just when we multiply all the roots together, the final combination, isn't it? Imagine you had your 4 brackets, that would be like the last 4 things multiplied together. The product of the roots would be e over a. And there's a pattern, like hopefully we can see that we've got like minus b over a, c over a, minus d over a, e over a, and like that pattern would continue with plus minus, and with these coefficients all being divided by a, and then you'll always end up on your product, okay? And start with the sum, which would be minus b over a. So we can start to summarise it like this. And I suppose technically they could ask about like a power 5, but if we look on the exam board and their teaching guidance, the most we're probably realistically going to get is a quartic like this. Okay. So what we're going to do now is similar to what we did with quadratics really, and just manipulate some expressions in terms of the sum, the product, and the pairs. Okay. Let's look at an example using these new relations between the roots that we've just found. And all we're going to do for this first one, we've been given a cubic and it just wants us to find the sum of the roots, the sum of the pairs, and the product. So the sum of the roots is equal to minus b over a, which would be 4. The sum of the pairs is c over a, which would be minus 3 over 1, also known as minus 3. Just realised while you're getting used to this as well, you might want to just know quickly like what a is equal to, what b is equal to, what c is equal to, and what d is equal to, just so you don't mess them up, because this will obviously be the first part of the question. And then the product of the roots is minus d over a, so that'd be minus 1 over 1, also known as minus 1. For the next one, we've got 5x cubed minus 9x squared plus 2. So the sum of the roots, minus b, so minus 9 over a, 9 over 5. And then the sum of the roots, the sum of the pairs, sorry, should be c over a. Just be careful with this one. We've got a, b, there is no x coefficient, so c would be 0. So c over a would also be 0. And then the product of the roots, alpha, beta, gamma, minus d over a, so minus 2 over 5. One last one. Here we've got 2x plus 9 minus 5x cubed plus 2x squared. Just be really careful with this one. I think we should be fine, but obviously we want to think about it as these coefficients need to be in the right order. Not necessarily that you write it like this, just as long as you understand what A is, what B is, and what C is, and so on. And then the sum of the roots. Minus B over A, so minus 2 over minus 5. So we get 2/5. The pairs would be C over A. So 2 divided by minus 5, minus 2/5. And the product, minus D over A, so minus 9 over minus 5. 9 over 5. Next example, we're given a quartic, and we're going to look at finding values of expressions in terms of the roots. Okay, the first four, we'll start with like the standard one, so the sum of the roots, the sum of the pairs. Don't forget that could be written there in short form. That's just the sum of the pairs. And this one, that's the sum of the triples. And then finally the product. Okay, so for these first few, the sum of the roots is always minus B over A. Okay, so it'd be minus 3 over 6, which would be a half. For the next one, the pairs is C over A. And don't forget C is this x squared coefficient. Now if you look at this one, we haven't got an x squared coefficient. So we just get 0, because it would be 0 divided by 6. For the triples, it'd be minus D over A. So minus D is the x coefficient. So we get minus 2. And for the product of the roots, we're back to E over A now. Okay, so that'd be minus 5 over 6. The last two, possibly pause and have a think about how you're going to do this, because they're going to take a little bit more working out. Like, we're going to need to use the information that we've got here and express these in terms of either alpha plus beta plus gamma plus delta or something else. Okay, so have a think about how you could do these two. So if we expand alpha plus beta plus gamma plus delta squared, I'm going to write it as 2 brackets multiplied. As we expand all this out, we're going to get alpha squared plus alpha beta plus alpha gamma plus alpha delta. And we can keep going. And we'd then get another alpha beta, a beta squared. And you might be able to just spot the pattern. Like, easy, as we expand this out, we're going to get alpha squared, we're going to get beta squared, we're going to get gamma squared, we're going to get delta squared. And the alpha betas, all these other little combinations are going to count twice. So you might spot that straight away, but let's just go through the process just to make sure. So we're going to get beta gamma plus beta delta plus alpha gamma plus beta gamma plus gamma squared plus gamma delta, and then finally alpha delta plus beta delta plus gamma delta plus delta squared. In other words, alpha plus beta plus gamma plus delta squared would be the same as all those squared terms, alpha squared plus beta squared plus gamma squared plus delta squared. And then if we add all these up, there's two lots of all of these pairs and combinations, which is just for shorthand. I'm going to write the sum of the pairs, but if you can see that it would be two lots of this thing here that we already know about. Okay, so if we rearrange, alpha squared plus beta squared plus gamma squared plus delta squared would equal this minus two of those. So the sum would be a half minus two lots of the pairs, which in this case is 0. So we would just end up with a quarter. Okay. And then finally for f, we've got 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta. And if we're going to add these together, clearly we need a common denominator. Think about what's going to happen here. Each of these values are going to have to be in each of our denominators. Oops. And overload on all the different letters. So we've got alpha, beta, gamma, delta. And for this one, we'd have to multiply the top and bottom. Now there's already alpha, so we just need beta, gamma, delta. This one was already beta, so we need alpha, gamma, delta. This one was already gamma, so it'd be alpha, beta, delta. And this one was already delta, so it'd be alpha, beta, gamma. And see what happens when we add these now. So as soon as we've got a common denominator, we'd get alpha, beta, gamma, delta on the bottom. And the top would be all of these added together, which is the sum of the triples. Okay, and the sum of the triples we know was minus 2. And the product of the roots is minus 5 over 6. Again, if you divide them by a fraction, flip and multiply. So a minus and a minus becomes a plus. So that'd be 2 times by 6 over 5. Also known as 12 over 5, just enough space to finish. Okay, so that's just giving you an idea about when you've got like a cubic or a quartic, the relationships between the roots and the pattern that follows. Once we've sort of got to go through this, next we're going to have to look at like how to form a new equation. You remember with quadratics we were like forming a new quadratic. We're going to do the same. So we're going to look at forming like a new cubic, or maybe even forming a new quartic, and that'll come next. Alright, thanks guys.